Hello, this is the Tepid Coder. So I'm continuing where I left off in the previous video, and I'm going to talk about having multiple tables that relate to one another. And for this, I want to have a new example. So instead of this user table where it's a one-to-one relationship and you just can select a specific user by its ID or its name and you can search for it wherever, I want to talk about how you can have data that's related to other data in a different table. So one thing I should show first, though, just to kind of cap off the previous video, is you can see we have like the tepid coder, fake coder, and supercoder. If I wanted to, I could actually pick how these records are given to me. Like right now, it's based on ID 123. So when I do select everything from users, you'll see it's actually ordered by the primary key by default. But what I can do is I can say sort by, order by, and I can say like stir username. I could say ascending, right? So now it's going to go by username. So fake coder comes first in the alphabet. And I can do the opposite too. I can say DESC for descending. Okay, now the tepid coder's first, supercoder, then fake coder. See that? So that's pretty cool. There's also things you can do where you can group it by something, and then you can also order within that category. And maybe I'll get into that later. But for now, like I said, I want to talk about having multiple tables that are related. So I want to consider something like books and authors. So imagine you have a book. The book can have an author, but it also might have multiple authors. So if it's like a math textbook or something, there's probably some peer review that went into it, and there's multiple people that like edited and authored it and whatever. Maybe each person handled like one or two chapters or something. Whatever. You could have something like that. Or maybe there's like something where a second author made a different version of it and published it with some corrections or some new, practice exercises or something in the book. Doesn't matter. Anyway, a book can have multiple authors. Okay, and an author can also have multiple books. So you can imagine the author has multiple books. So it would be kind of weird to have a situation where you have a book. Let's say the book is called Super Neato Book. Okay, this was written by some dude. All right, but it was also co-authored, Super Neato Book, by Girl 2, whatever. So you got like some dude 1, you got some girl 2, whatever. You don't really want to have two instances of this record and have them point to different authors. That'd be kind of silly. You can do better than that. You can make it so that there's a table that both of these tables are referenced by, both the book table and the author table. I usually call this like a pair table. I don't know what the formal term for it is, but it's basically like a map or a lookup. So what I'm going to say is I'm going to have something like create table, let's say books. Okay, let's leave that empty for now, and create table, let's say authors. Okay, and what I'm going to do here is I'm going to say create table book author pairs. Okay. So what I'm going to do here is I'm going to imagine I have an identifier that's unique for the books, identifier unique for the authors. And I'm going to look at these two identifiers inside of this book author pairs table. So I'm going to say I have integer, not null. It's going to be the type for each of these, integer, not null. And I'm going to call this one a book identifier. I'm going to call this one an author identifier. Okay. So what I can do is I can iterate through this table, and I can look for which books are related with which authors and which authors are related to which books. So then if I'm looking up like a book, searching it by its name or something, I can get the ID of the book, and then by that I can find all the authors involved, because it's going to have multiple book author pair records for the same book if there's more than one author. And if one author has more than one book, it's going to have more than one of these records so that the author can have like all of its book associations. So you'll essentially have something like, I don't know, let's say the tepid coder is an author, right? It'll have like an entry in the book author pairs table. So if I look at this, it's going to have something like, let's say my ID is 1, okay? And the book I wrote is also ID 1. And then there's going to be a second record down here. I'm ID 1, and then I also wrote book ID 13, you know? And then the next record, ID 1, I wrote the book 27, whatever. It's going to have just a bunch of entries like this, where you can say like the author ID, this case me being 1, whatever, is associated with like book 1, book 13, books 27 database. And then you're going to have some kind of like a books table, which is going to have something like ID 1 is like the way to program. And maybe you'll have another record which is like, okay, book 13 is going to be ORMs are bad, and you should feel bad if you use one. Okay, and maybe book 27. How frameworks will eat you alive. Whatever. So I have these books, and in each of these books can be mapped to this table, book author pairs, and you can also get my author ID from that, because you're looking at like book 1, you looked at the way to program, and based on 1, you said look at the table in here, which matches the book ID 1. And from that, I can get the publisher or other author ID from this table that matches this key. So then you get the type of coder from that. So I'm going to kind of show how that works. In fact, maybe I'll even use these exact examples, right? Or I don't know if I'll keep the IDs that spread out, but I'll do something like that. So books, I'm going to say something like stir book name. Okay, I'm going to say it's text because I'm going to be lazy, not null. Book has to have a title. Okay, so let's say I also want ID integer primary key auto increment. It's nice that it filled that in for me. Okay. Anything else I would care about with this? I mean, I could look into like having publishers and stuff, but I want to do the same kind of a pair table like that for a publisher and stuff too. So I'm going to keep that simple. So authors, let's just say I have, I'm going to steal this, ID primary key. I'm going to say stir author name, text, not null. Okay, so the author writes some books. I mean, the book would really have like an ISBN number and whatever, but in this case, we're just using the ID of the book or whatever and the name. Okay, then we have book author pairs. Let's start creating some stuff here. I'm going to insert a new author, so insert into authors, and we're going to say stir author name. Okay, and values we're going to insert are going to be the tepid coder. Okay, and then insert into, I'm going to do, what is it, books, and it's going to be stir book name, I think I called it, values, and I'm going to say, what was the example I gave? The way to program. I'll be even more snarky. The only way to program. If you're not doing it my way, you're doing it wrong, apparently. Okay, so let's take the other titles here. Arms are bad. Okay. In fact, I'll do like this. Make it a very sophomoric. Why you should feel bad if you use one. There we go. It's got the subtitle and everything. What else here? How frameworks will eat you alive. Okay. I don't want a period at the end. Okay, so let's actually run these. Yeah. In fact, I haven't even created the tables yet, so let's just run all of this. Boom. Any errors in here? Where are we? Selecting that, selecting users, where are we? Create table books. Here we are. So we created that, looks like it worked. Created that, worked, okay. Yeah, I think we're all good. So let's go to the bottom here. And let's say select everything from authors, just real quick. Okay, I'm in there, good. Select everything from books. Okay, there's the books. Now what I want to do is actually insert association between these. So I'm going to say insert into book author pairs, and it's going to be something like book identifier. Yeah. And I need also author identifier. Yep. Values. All right, so let's say I wrote book 1, okay, and my ID was 1, so those are associated. Cool, so let's do that. Okay, I also wrote, let's say, book number 3. Let's say I didn't write ORMs are bad, even though I really hate ORMs. It's one of the things that really make me a tepid coder, to be honest. I think they're terrible. Let's see here. Thing from authors. So yeah, it was 1. Books is... Yep, okay. So what I can do now is I can find... How do I want to word this? I'm just going to iterate through these book author pairs real quick, and then I'll explain as I do that. I think it'll be easier to understand. So select everything from this. From. Okay. So you can see right here, book 1 associated with author 1. You have book 1 associated with author 3. So I did that backwards, actually. That was a mistake. So I'm going to fix that. Update book author pairs. I'm going to say set, let's see, author identifier equals, in fact, I'll make it even easier. Just delete from book author pair, come on, where author identifier equals 3. There we go. Now if I select from that again, it's going to set that one record. So I did these backwards. What I wanted to do is say book 3 is also associated with author 1, which was my author. Okay, so now if I select this again, you can see that there. Okay, so author 1 wrote book 1 and also book 3. So what I want to do now is I want to show how to do something called a join. What you can do is you can select everything from here. I'll say BA pairs is going to be the alias for this table name that I'm selecting from. So grab all the records from book author pairs, which are both these. Okay, and then when I do that, I want to figure out what the book name is and what the author name is that's being referenced by this. Okay, so I'll expand it, make it more difficult, and do more things with it in a second, but I just wanted to get that basic thing working. So what you can do is you can say inner join, let's say authors on, sorry, A for authors, on A dot stir, or not, I'll say A dot ID equals BA pairs dot author identifier. So we're looking through all of this table right here, and it has a book identifier and an author identifier. And I'm saying, look at that author identifier from that table. Each one's called BA pairs for that record. If its author identifier matches author's ID, so it's the same identifier, then we're joining that authors table and calling it A. So if I select over here, I can say BA pairs dot, like, everything is being shown, comma, and I could say, like, A dot, everything is being shown, so the authors table is showing all its stuff that matches. And I'm going to go one more further and say inner join. I'm going to say books B on B.id equals BA pairs book identifier. So now I can say I want to have everything from the book table that matched. So let's try that real quick. Cool. So you can see book identifier was 1, author identifier was 1, and that author identifier matched stir author name tepid coder, and the book identifier 1 matched the only way to program. And you can see book identifier 3 matched how frameworks will eat you alive. So that's essentially how that works. And what I can do here is I can actually modify this a little bit. I'm going to make it so that I select these things where it's going to be the book has some name. So I'm going to say, like, what did I call that for the book name? Let's close this one. Books, columns, stir book name. So I'm going to say where stir book name equals, or say is like, I think it's just like. And if you do present signs, it's a wildcard. So I'm going to say how, like how frameworks will eat you alive or something. So anything that includes how anywhere in the text. Could be the very beginning, could be the very end, could be in the middle somewhere. Okay, but I can't actually do that because I'm not selecting from the books table. I'm selecting from the book author pairs table. So I can do something called a subselect. So where, let's say, BA pairs dot book identifier equals, okay, and I'm going to do what's called a subselect. Select ID from, it's going to be books, where, that. So that should work. So basically, select anything from this book author pairs table where it has the ID for the book, which matches whatever the result of this query is. In this query, if I just run this, just that subquery, I get a 3, right? So I'm looking for any book which has how in the name, basically. So I'm getting 3 from that, and this whole thing is checking to see for any book author pairs which has a book name. If I go to right here, columns, it's going to look for a book identifier which matches that. Matches this 3 right here. So let's actually put that in, put a 3 here. Okay. I'm going to comment this out, and you'll see it'll be the same. So, boom. So book identifier is 3, author identifier is 1. That's what the book's called. There's the author name, there's the book ID, there's the author ID. It's kind of redundant because I'm selecting everything from it. I really don't even need to show this. This is just kind of for the sake of an example. So there we go. It's a little less redundant. And I still don't want things like the ID, so I really should just say like author.stir author name. I should say b.stir book name. Right, keep it as simple as possible. Yeah. Now let's actually bring this subselect in here. A selection statement which is being either shown inside of the results here. You can do it over here too. I can say the same thing, like select ID from, how about authors, where stir author name equals, you know, the tepid coder. I could do that too, and say as something. That'll work too. It's going to show up in every single row though if I do that. So something's 1 right here. So you can do subselects there to get a result, but you can also use those results to match things. So that's what I was doing there. Okay. Anything else I want to talk about with this? So essentially I'm able to search for any books that match some title, and I'm able to get the author or authors which match that book. Now let's imagine someone helped me write this book. I'm going to create a new author here. So insert into authors, oops, use backticks, stir author name, set values, okay. Very helpful assistant. Okay, so a very helpful assistant. Oops. Okay, and what we're going to do here, insert into the pairs. First of all, let's bring back PA pairs asterisk for a second, so I can actually get the ID of that book. So it's ID 3. So I'm going to say author identifier number 2, very helpful assistant, also helped write book 3. Okay, so now if I select this, it should show both of those. So here we go, book identifier 3, author identifier 1, and book identifier 3, author identifier 2, and here's the other name, very helpful assistant. And we both wrote this book together. So that's pretty cool. And you can go pretty wild with this. You can have all kinds of joins in here. Like maybe there's any number of publishers that have published a book, but a different version of the book at one time or something. Or maybe you can also be like an independent publisher and you publish for yourself, and you can get all the books from a publisher. You can get all of the books that have a certain publisher. So you can do it in reverse. You can find all authors which used a publisher at one point, or all publishers which used an author, right? Maybe one author has multiple publishers they've used for their career. So it's really cool that you can do this using such a concise language like this. It can be sometimes kind of confusing to do certain operations in a database, but it's well worth it because you're able to have a storage medium which is pretty compiler agnostic when you're working with something like a database engine like MariaDB or PostgreSQL or Sqlite even. So the issues I've shown before when I was talking about things like bit fields in C++ and how they're not going to be, what do I say, homogeneous across executables made by different compilers even using the same structure definition. You don't have that issue here because the storage medium has its own way of storing things which is guaranteed to work when the API is used by multiple different programs compiled with different compilers. So you get those kind of guarantees. And you also get things like sorting on different columns for free, right? I think that's pretty cool. And over here I can do things like order by, let's say, stir author name, which comes from A, so it's A dot that. So I can even, there we go, it's the same order though. So let's do order by that, descending. It's ascending by default, by the way. I'd have to put the ASC there. So there we go, now the very helpful assistant was first, because I'm doing it in reverse alphabetical order. Okay, so I'll think about maybe things I might want to do for future Sqlite3 videos, but for now, I think I've covered 90% of the stuff you'll use on a day-to-day basis. There's things like time conversions you want to do. There's calculations you can do inside of the query if you don't want to make the calculations afterwards. Like I can select like between a join date and the current date, and I can find out like how many days have elapsed or seconds or something. But these are such small, rarely used things that you can probably look them up. If I see interest in it, maybe let me know in the comments if you're interested in seeing more stuff about SQL in general, or specifically Sqlite. And I'm certainly willing to make more stuff on this, but I mostly just wanted to have a primer here to, what do I say, undergird the current Sqlite3 videos that I've done within the context of its API being used by C++ inside of some variadic template functions wrapping it. Anyway, I think that's going to about do it. If you liked the video, please give it a thumbs up, consider subscribing for more content like this, and I will catch you in the next one. Happy coding, guys.